Imagine driving through a city you've never visited, no road signs, no directions, yet your phone knows exactly where you are, every turn, every street, every destination. Within seconds, it feels like magic, but it isn't. Behind every navigation app lies one of the greatest engineering achievements in human history, a system floating more than 20,000 kilometers above Earth, working every second, every day, without stopping. This system is called GPS, the Global Positioning System. Billions of people use it without ever thinking how it actually works. How can a device in your pocket know your exact location anywhere on Earth? How do satellites measure your position within just a few meters? And what would happen if GPS suddenly disappeared? Planes could lose navigation, ships could drift off course, emergency services would slow down, banks, power grids, mobile networks, and even the internet be affected. Today, we're uncovering the incredible science and engineering behind GPS, the invisible technology that quietly guides the modern world. Long before smartphones existed, finding your way was far more difficult. People relied on maps, compasses, road signs, stars, and experience. A single mistake could send travelers miles in the wrong direction. Then, everything changed in the late 20th century. Engineers and scientists created a system like anything the world had ever seen. Instead of placing navigation towers across the Earth, they placed the technology in space. Today, more than 30 GPS satellites orbit our planet, moving at nearly 14,000 kilometers per hour. Each satellite circles the Earth twice every single day. From so high above, they can see almost half of the planet at once. No matter where you are, in a city, on a mountain, in the desert, or far out at sea, at least 4 satellites are almost always above you, silently sending signals toward Earth. Not pictures, not videos, not internet, just extremely accurate time. Every satellite carries atomic clocks, among the most precise clocks ever built. They lose less than a second over millions of years. That accuracy is the secret behind GPS, because your phone doesn't ask the satellites where it is. Instead, it measures how long their signals take to arrive, and from that, it begins calculating your exact position. Every signal travels at the speed of light, nearly 300,000 kilometers every second. Even a tiny error of 1/1,000,000th of a second could move your location by hundreds of meters. That is why time is everything. Your phone receives signals from multiple GPS satellites at the same time. Each one sends its exact position and the exact time. The signal was transmitted by comparing when the signal was sent to when it was received. Your phone calculates the distance to each satellite. Imagine drawing a giant sphere around one satellite. You could be anywhere on that sphere. Now, at a second satellite, the possible location becomes much smaller. A third satellite narrows it even further, and with a fourth satellite, your phone finds your precise location. This process is called trilateration. It happens in just a fraction of a second without you even noticing. Every time you open Google Maps, book a ride, track a delivery, or share your location, your phone repeats this incredible calculation again and again every single second. But GPS is not perfect. The signals travel more than 20,000 kilometers before reaching your phone. Along the way, they pass through Earth's atmosphere, where tiny changes in temperature and charged particles can slow them down. Tall buildings reflect signals, mountains block them, dense forests can weaken them, even bad weather may reduce their accuracy. That is why sometimes your blue location dot appears a few meters away from where you are actually standing. Engineers have developed advanced correction systems to solve these problems. Ground stations continuously monitor GPS satellites. They measure tiny errors, update satellite information, and improve positioning accuracy. Some modern systems can determine a location within just a few centimeters, precise enough to guide construction equipment, survey land, help farmers plant crops, and even support self-driving vehicles. Without these engineering improvements, modern navigation would never be as reliable As it is today, every accurate location on your phone is the result of thousands of engineers working together. Across Earth and space, GPS does much more than help people navigate every day. Commercial airplanes use GPS to follow precise flight paths. Cargo ships cross vast oceans without losing their direction. Emergency responders reach accident scenes faster than ever. Farmers use GPS-guided machines to plant crops with incredible precision. Construction companies build roads, bridges, and skyscrapers using exact GPS measurements. Even financial markets depend on GPS not for location, but for time. Banks, stock exchanges, mobile phone networks, and power grids need perfectly synchronized clocks. GPS satellites provide that precise timing every second. Without it, many digital systems would quickly fall out of sync. This invisible service keeps modern civilization running smoothly. Most people never realize that every time they make a phone call, withdraw money, order food, or use mobile internet, GPS is quietly working in the background, not just to tell you where you are, but to keep the world's critical infrastructure perfectly synchronized. There is one question that engineers always ask: what happens if GPS stops working? The answer would affect almost everyone. Airplanes would switch to backup navigation systems. Ships would rely on traditional marine navigation. Drivers would lose real-time directions. Delivery services would slow down. Emergency response could take longer. Mobile networks might lose accurate timing. Financial transactions could become less reliable. Power grids would face serious synchronization problems. That is why countries never depend on GPS alone. Many also use other satellite navigation systems. Europe has Galileo. Russia operates GLONASS. China uses Beidou. Together, these systems improve accuracy, increase reliability, and provide backup if one network experiences problems. Modern smartphones can often receive signals from several satellite systems at the same time, making navigation faster, more accurate, and more dependable. The future of navigation is no longer just about finding directions. It is about building a safer, smarter, and more connected world, all made possible by satellites silently orbiting high above our heads. The next time you open a navigation app to find a restaurant, a friend's house, or simply your way home, take a moment to think about what is happening behind the screen. Signals traveling from space, atomic clocks keeping perfect time, satellites orbiting Earth at incredible speed, and billions of mathematical calculations taking place in an instant. Also, a small blue dot can tell you exactly where you are. GPS is more than a navigation system. It is one of humanity's greatest engineering achievements, a technology that transformed the way we travel, build, communicate, and explore a world invisible, silent, always working, connecting space with everyday life. Proof that the most powerful technologies are often the ones we never notice. And as humanity moves toward autonomous vehicles, smart cities, advanced robotics, and missions to the moon and beyond, GPS will remain one of the invisible foundations of our future, a masterpiece of engineering orbiting high above the Earth, quietly guiding billions of lives every single day. If you enjoyed discovering the hidden technology behind GPS, don't forget to like, share, and subscribe, because here we explore the world's greatest engineering marvels, space technology, mega projects, scientific breakthroughs, and incredible systems that quietly power modern civilization. Every documentary reveals the engineering behind the things we use every single day. Thank you for watching, and we'll see you in the next documentary.